Section 2.6 online help session. How about number one? You good? Okay with number one? Yeah, sure, sure can. Um, it's going to take a picture of the whole thing. I don't know why it's doing that. There we go. Let me X out that. Get back here. It says solve the following exercise. Solve the rational exponent equation. Use factoring when necessary. All right, so it's not. Okay, so here's what you got to make sure you understand. First off, let's make sure that this right here is not working. All right. We've got x to the 3/4 equal to 8. All right, so it's a rational equation because the exponent is a fraction. Okay, so that's how you know that it's a rational equation. The exponent's a fraction. Now, I want you to think about it's 3/4, right? It's raised to 3/4. Fraction. This is really, if you look at it like this, it's really like that. So I could take this x to the a over b, make it look like that, or in terms of the other one. So rational numbers are fraction numbers that can be expressed in the form of a over b, right? So that's how that comes about. Now, but I want to show you something real quick. That's theory, right? So what we're going to do is this. We're going to raise both sides to the reciprocal of 3/4. And the reason why is we can apply the power to a power rule, right? The power to a power rule means that if you have something raised to a power, raised to another power, you can multiply those powers. Well, 3 times 4 is 12, 4 times 3 is 12, so 12 over 12 is nothing more than 1. So it takes x and makes it to a power of 1, right? Now this one, this is 8 raised to the 4/3, right? So what I just showed you with the x to the a over b, this is really, I like this format better than anything. We're going to convert this 8 to the 4/3 over into this form. So what it's going to be is this. It'll be the cube root of 8 raised to the 4th power. Well, the cube root of 8 is nothing more than 2. And 2 raised to the 4th power is nothing more than 16. Now your calculator, you can take 8 and raise it to the 4/3 power, and it will give you 16. Okay? You you can do that on the calculator. But you need to make sure that the 4/3 is in parentheses, or if it's in math type where it writes it all up there, make sure of that. But that's the premises behind here. Um, fair. Do do what now? Like this? Let's see. Um, hit submit. Okay. And we'll try a similar one. Okay. I'm not sure if you can see that, but 3/2 equals 27, right? So just problem number one. There you go. So I'll hit pause and I'll let you just see what you can do, okay? All right, so what I'm going to do is it's x raised to 3/2, so I'm going to raise it to the 2/3 because that would be the reciprocal, right? What you do to one side, you got to make sure you do to the other, right? So your x, that cancels 606, it just gives me x to the first. Now, you can evaluate 27 raised to 2/3, right, on your calculator. But I want you to get used to doing this. Rewriting, the denominator is the root, right? The denominator is the root. So it's the cube root of 27 squared, right? And the cube root of 27 is nothing more than 3. 3 squared is, guess what? 9. There you go. So that's how that works. And the rewriting it from a fractional exponent over into a radical representation is crucial. Okay, knowing how to do that and getting comfortable in doing that is so crucial. Okay, so just kind of remember that. Yeah. Okay. All right. Huh? All right. So solving square root equations, right? Yeah. It's where you got to do it. There's one type where you got to do it once, and then there's another one where you have to do it twice, right? Yeah. Okay. So let's see that would probably be number 9. Nope, it ain't. Number 9, number 11. Huh? Did I take it off? Nope. Did I take it off? No, that's the 4th root. Nope. I took that. Hmm. All right, so we're going to work number 4 just so we make sure that we're okay on this, right? And then we'll go, huh? And then we'll work up to number 9. Fair enough? And then that's just about it. Yeah. Okay, let me go here. Says the following exercise. Make sure I read. Be sure to check all solutions to eliminate extraneous solutions. So extraneous solutions, from when I taught it on the lecture, is a solution that you get, but it doesn't satisfy the equation. You solve for it, but it just doesn't do it. So what we're going to do is when you have a radical equation like this, the key to it is to isolate the radical. That is what you're trying to do. Okay, so what we're going to do is we're going to add 5 to both sides. So that's going to leave us 2x plus 3 equals 5. Yep, and we'll square both sides because that's a square and undoes the radical, right? So 2x plus 3. When you square square root, it cancels it out, right? Yep. And then from here, it's minus 3, and then we get 2x equals what? 22x equals 11, right? Okay, now it said to check for extraneous solutions. So what I'm going to do is I'm going to plug 11 back in. So 2 times 11 would be 22 plus 5 would be, plus 3 would be 25. The square root of 25 would be 5. 5 minus 5 equals 0. So 11 checks out, right? Did that make sense? So when you do this, this is 25 minus 5. So does 5 minus 5 equals 0? Yes, it does. Okay, so that's 11 is a viable solution, and you have to check because it could possibly have an extraneous root, right? Meaning an answer that you got but just doesn't satisfy it. So this is the whole premises here. We're going to isolate the radical, and once we get that radical isolated, meaning just the radical on one side, we'll square everything, right? So that was, I think, number 4, right? When that number 4 or something. Want to go back here. I think number 7. Look at it real quick. It is nothing more than you're going to square this binomial, right? So are you okay on this type problem right here? All right. Yeah, the polynomial theory in it. So you can use it, but I mean you can just FOIL it out. It doesn't really matter. Um, so yeah, but here's your thing now. When you're copying those notes, you need to make sure you need to try to work it, because if what you're doing, what you're copying down doesn't make sense, you need to stop it, back it up, go back and look at it, and make sure you're, try to figure out what I'm doing. And if you still can't after you go back and look, then you need to make notes and say, hey, on this one, I got this far, I just didn't know what else to do. So yeah, but if all you're doing is copying notes and not understanding how we're working them, then when you get to work the problems in the homework, it's not going to be beneficial, because what have you done other than just copy down notes with no thought process? I hate to say no thought process, with full understanding of what you did, right? Does that make sense? So yeah, okay, yeah. Well, we're going to get them. We're going to get you straight here, okay? Um, so now we have a radical isolated, right? So what we're going to do is we're going to square it, and then we're going to square this side over here. And what that becomes is we have 2 of these, right? The right side is easy because it just cancels out the square root, not a problem, right? Now we're going to FOIL, right? A times A and A times 1, so it's A squared plus A, and then 1 times A is A, and 1 times 1 is plus 1. So we've got A squared plus 2A plus 1 equal to 3A plus 3, right? Yeah, A squared plus 2A plus 1. Now we're going to move everything over to one side. That's going to give me a negative A plus 1 equals to 3. And then we're going to move the 3 over to here, which gives me A squared minus A minus 2 equal to 0. Equal to 0, right? So what I did was, once I got this side right here, I took the other side and moved it over. I took the green over to the right hand or to the left hand side to get everything equal to 0, right? Because we have a quadratic now. Right, we got A is 1, B is negative 1, C is negative 2, right? So right here is A times C. So 1 times negative 2 is negative 2, right? And then this is, right? So, so it's going to be, 1, 2, and the biggest number has to have the sign of the B, right? So that's a negative there. So what we're going to end up doing is really having this A plus 1 equal, all right, and then A minus 2 equals 0. And then this is the factors, right? So set each factor equal to 0. And then we'll plus 2. We'll say A is equal to 2. On this one, we're minus 1, so A is equal to negative 1. So our answers for right now are negative 1 and 2. Now, we don't know if that works. We need to check it. Negative 1. 3 times negative 1 is what? 3. Negative 3. Plus 3 is what? 0. So I got 0 on left-hand side. So negative 1 plus 1 would also be 0, right? So negative 1 checks out, right? Okay. Now let's go check. We got 2, right? So 2 plus 1 is what? 3. And then 3 times 2 is 6. 6 plus 3 is 9. Square 9 is 3. So boom. So negative 1 and 2 all check out. So on these radical type equations, not only do we have to solve them, right? We have to turn around and check our answers to look for extraneous roots. And this particular one right here, because it's going to give you a quadratic, and because it's algorithmically generated, the quadratic that you're left with should be factorable. Okay? Oh, I plugged in 2. I got A minus 2 equals 0, move 2 over, so A equals 2. Right? I'm not plugging in these right here, okay? I'm not plugging in these. I am plugging in the yellow. because you got to set them equal to 0, right? Yeah, 2 plus 1 is what? 3. And then 3 times 2 is 6, plus 3 is 9. Square root of 9 is 3. Yeah. So this is all checking here, right? All right. So that's the second really good second look that you'll see on these radical type equations, okay? Now the one that's going to be a meat and tater. What I mean by meat and tater is it's going to take about a page, page and a half, because not only do you have to square it one time, you have to square it twice, and that would be number, what did I say, number 9? Yeah. So what we're going to do is we're going to look at this, and now I'm not going to use y's because I hate y. I'm going to use x, okay? So I'm going to rewrite this in terms of x. So square root of x minus 1 plus 1 equals square root of x plus 2, right? Now, I have to ask myself the question, do I have a radical isolated? And I do. The radical that I have isolated is the square root of x plus 2, right? So what I'm going to do is square it. But look what look what I got over here. I've got to square this as well. So what it's going to give me, yeah, it will. It'll be very much like what we just did on the previous problem, but it'll be, now when I square root there, it's just x plus 2, right? So the right-hand side is just going to hang out for a little bit. So watch what I'm doing here. This first term is going to be multiplied times everything over here in the second parentheses, right? So the square root of x minus 1 times the square root of x minus 1, well, that's the same thing times itself, which is really squaring it, right? So what you get is just x minus 1 when you do that. Then when you take the square root of x minus 1 times 1, you get square root of x minus 1. Okay? Now, yeah, let me do this. This times that, those are two things that are the same, right? And if they're multiplied, then that means they're perfect squares, right? So if you take two square roots that are the same and multiply them times each other, then it will square, it will, it'll erase it. So really this square root of x minus 1, when these two yellows are really, well, I mean, well, it when you're multiplying them, it's really treating them like this, right? Because I have this square root of x minus 1 times square root of x minus 1. It's squaring a square root. So really it's going to leave me with just x minus 1, right? That's really, the two yellows being multiplied gives me the red over here, which is just that. Okay? That's a pattern. That's going to happen 100% of the time. Okay? You take it to the bank. It's going to be that way. And then I've got square root of x minus 1 times 1 is just itself, right? And then I start with the second term, plus 1 times that, so plus square root of x minus 1, and then 1 times 1 is 1. That's equal to x plus 2. Now what I'm going to do is kind of combine like terms, right? So you can see that these 1's cancel out, right? I got a plus 1 and a minus 1. So I got x plus 2. Yeah, there's a coefficient of 1's, right? If you got light radicals, you add their coefficients. Okay? Now, I need to isolate this radical. So I'm going to minus x. So 2 square root of x minus 1 equals, well, that's going to be 0, right? It's just going to leave me with 2. Because x minus x is 0, right? Now, I haven't got that radical isolated yet because I have to divide it by what? 2. So what that's going to leave me is this. Now, because 2 divided by 2 is 1. Now, see, this is 2 times that. 2 times the square root of x minus 1, because you have a coefficient of 1 here and a coefficient of 1 here on the x square root of x minus 1. You add those coefficients. If you have light radicals, you add their coefficients. So it gave me 2 square root of x minus 1 equal to 2. This is 2 times it. Well, in order to do the inverse operation, if it's 2 times, I have to divide, which would mean I divide this side by 2 and divide that side by 2, which would leave me, yeah. All right, now I can, guess what I can do? Do it again. There you go. So this cancels this, the square cancels the square root, leaves me x minus 1, and 1 squared is 1. And then I'm just going to add 1. So x equals, guess what? 2. Now, I'm not sure if that 2's even a viable solution. After all that work, it could have been just a fuddy-dud, right? So let's go check it. Let's go up here. We're going to plug it in, right? 2 minus 1 plus 1, 2 plus 2. Well, 2 minus 1 is what? 1. And the square root of 1 is what? 1. 1 plus 1 equals 2. The square root of 2 plus 2 is 4. The square root of 4 is 2. So 2 it is, right? So the answer checked out as being a viable solution and not an extraneous root. All right, so let's look and see what problem there is left. There's not too many left on here because they ain't but 6 or 7. So that's number 9. So you get a choice between 11, yeah, and 12. Okay. Yeah, yeah. Um, so I can teach, I'm going to teach number 12 to you real quick just to make sure you're okay. All right, so you have an absolute value equation. All right, you cannot have an absolute value. Well, let me put it like this. You have to isolate, in order to solve an absolute value equation, you have to isolate the absolute value, meaning the only thing that can be on that side is the absolute value bars and everything in between those bars, right? Nothing on the outsides. Okay, if they are, you got to manipulate. You got to either divide or multiply to get everything away from it, just so you isolate that absolute value. Now, The absolute value is defined as the distance from from a number back to zero. Okay. Now distance can ever be negative. So therefore, like if I said, here's 0, here's 5, here's -5. If I said the absolute value of 5 is 5, and then we also learned that the absolute value of -5 is, guess what? 5, right? Because we're looking at a distance, right, from that number back to 0. So we can never ever have a negative number. An absolute value can never ever be equal to a negative number, period. Okay. Now, what you have to understand is you can have what is called a negative equation and what is called a positive equation. So what I'm going to do is so I'll go positive, and then over here I'll go negative. Okay. Well, let me kill some of that right there. And I'll just do it like this. All right, so we put whatever's in the absolute value goes on both of them, right? And the positive equation is identical to what's up here, except it doesn't have the absolute values. Okay. The negative equation has everything underneath the absolute values, but on the right hand side, it will multiply the right hand side by -1. So this is really -1 times 6, right? Which is -6. So that's what we're going to do. Instead of having to manipulate the absolute value side of the equation by having a -1 over there, we can just multiply the right hand side and take care of it over there, and it'll work out. So what we've got is now we can just solve, right? We have two answers because there's two possible things: distance to the left and distance to the right, right? So that's 0, so A equals 0, right? I do that right? Yeah. And then from here, so I've got A is equal to 4, right? Right? So yeah, I did. I just didn't show it. I can go back and show it. I'll do it real quick. Yeah, I still have to do that. And so what I want to show you is if I were to plug 0 into here, you would have the absolute value of 6 equal to 6, right? Check. That agree? Okay, now if I were to plug 4 in here, you'd have absolute value of 6 minus 12, and 6 minus 12 is the absolute value of -6. Does -6, absolute value of -6 equal 6? Yes, it does. So our answer is 0 and 4. That's the answer for the variable, right? And that's it, my friend. That's all you got to do. The only thing you have to worry about is the positive equation looks identical without the absolute values. The negative equation of it looks identical, except the right-hand side has to be multiplied by -1. Whatever's on that right-hand side has to all be multiplied by -1. Okay, because it has to take care of the negative side of the equation, all right? But that's it. Okay. Good. Okay. And that's it, I think. I think that's so. All right. So you good on 2.6, right? Oh, we're on 2.6. Yeah. 2.6. Yeah. All right. So what I need for you to do is just concentrate on working on 2.6 between now and tomorrow, because we got another help session tomorrow night at 7 o'clock, and that will cover 2.7. Okay. Note that y'all also, and I say y'all because this is going to be put up online and people can listen to it. Y'all also have chapter 1 test that is due this coming Sunday, right? I think I think a lot of people have already taken it or should have already taken it by now because it's been open for a while. But if you haven't, you need to go ahead and get it done so you can really concentrate on chapter 2, because we're 2.7, I think, is the end of chapter 2. So this weekend ends chapter 1's test. Next weekend will be chapter 2's test, right? So every weekend will be a test, just about. Okay. So just kind of make sure that you're aware of that and keeping up. All right.